Okay. Okay, everyone. Welcome to this. This is number 4 on the homework. We will be doing chapter 3, problem 20, which is Adirondack Savings Bank. So oops. So let's begin with this. Let's look at the problem and then we'll come up with there are three decision variables here. Oops. Right. So the three decision variables are we have $1 million in funds and rates of return are 7% for home loans, personal loans, and 9% for automobile loans. So here again, we have an option of either defining them as percentages or dollar values. Because we're given the $1 million, I'll go with dollar values. But again, if we did it with percentages, you'll end up with the same answer, right? So it was, home loans, personal loans, and automobile loans. So at HB, the dollars set aside for home loans, P is dollars, right? Dollars set aside for personal loans, and oops. And A will be the dollars set aside for automobile loans. All right. So those are our decision variables. Now let's write the objective. So the objective here is to maximize the rate of return, right? So formulated linear program that can be used to determine the amount of funds ASB should allocate to each type of loan to maximize the annual total return. So 7% for home loans, 12% for personal loans, and 9% for automobile loans. So I'm sorry, 7, 12, and 9. So 7% for home loans. So 7% times the amount of money that you set aside for home loans. That's how much money you're going to get back. 12% for personal loans plus 9% for automobile loans. So a couple of things. In reality, whenever you set aside money for loans, and even if you expect to give out all of that money as loans, you don't always get back everything. So there's always a certain percentage of people who are not able to pay or don't pay because there is some fraud or something like that. So there's always a percentage of money that you're not going to get back. But here we are assuming that none of that exists. But if it did exist, you can figure that out. You can build that in, right? So you can build that risk factor in. So if you have a 10% risk factor, then you just do 1.1 times, 0.9 times A here, for example. 90% is all you're going to get back on, right? So that's another thing that you can do. But anyway, that's the objective. Now let's write the constraints, right? Let's write the constraints. How much should be allocated with interest? Okay. We'll come to the sensitivity analysis bit in a second. So bank planning committee has decided to say at least 40% of the new funds must be allocated to home loans. At least 40% of the new funds. So home loans have to be at least 40% of the new funds. So it's $1 million. So 40% of $1 million is 400,000. So again here, if you had done these as percentages, you could have just written H is greater than 0.4, right? In addition, planning committee has specified that the amount allocated to personal loans cannot exceed 60% of the amount allocated to automobile loans. So 60% of the amount allocated to automobile. So personal loans cannot exceed, so less than or equal to 60% of what is allocated to automobile loans, right? So that's the constraint there. Cannot exceed 60% of the amount allocated to automobile loans. There you go. So that's it. Those are the constraints. Other than this, obviously, there's the total amount of money that we have. So H plus P plus A has to equal to 1 million. Right? There you go. So this constraint here, obviously, I'm going to rewrite this constraint as P minus 0.6 A is less than or equal to 0. So we have 1 equal to, 1 greater than, 1 less than. I guess I could have moved the P to the other side. No, whatever. So we have these three constraints, right? Let's see. Am I missing anything? $1 million in new funds. The annual rates of return. Banks 40%. of the new funds must be allocated to home loans. In addition, planning committee has specified that the amount allocated personal currencies. That's it. That's all we have. Okay. With this, let's put this into solver and solve it, and then we'll generate the sensitivity analysis and go from there. So this was chapter 2, case 2. This is production something. So I'm going to do that. So now we have chapter 3, problem 20. All right. Okay. So we have 3 decision variables. So we have home loans, personal loans, and automobile loans. Of course, left hand side, right hand side. Let's get that done. Okay. Decision variables. Right. And the objective. And then constraints. So, right, we'll get to the constraints in a second. So these are my decision variables right here. Okay. So the objective function, so it's a 7% on home loans, 12% on mobile loans, and 9% on automobile loans, right? So let's do this. 7, 12, and 9, yeah. Okay. So that's that, and that's the objective. Now the constraints. First one is the constraint on the total money that you have. So that's, I'll just call it the budget constraint. Budget constraint. So H, 1 times H plus 1 times P plus 1 times A should be equal to 1,000,000, right? That's the first constraint. So second constraint is on home loans, and the third constraint is on personal and automobile loans, right? So home loans is that it has to be at least 400,000 of the total. So home loans, this is personal and auto, right? So home loans have to be at least 400,000. Now home loans do get us the lowest rate of return, so very likely we'll just allocate 400,000 to home loans. Now for personal and automobile loans, the constraint was that P minus 0.6A is less than or equal to 0. So let's put that in, P minus 0.6A. P, 1 times P minus 0.6 times A, sorry, 0.6 times A is greater than or equal to 0, right? So those are my constraints. Now let's write the object. Some product of the coefficients and the decision variables, which have to be absolute references, right? I'm going to copy it down. That's my objective function. So there you go. Okay, so the formulas are in. Let's go to solver. So it's a return maximization, so profit maximization. I'm going to keep that. So the objective is right there. Okay. Now the decision variables. These are the 3 decision variables that I have. Now the constraints. So I have to have one constraint of each type. So I'm going to write all 3 constraints separately. I'm going to add. Okay. So this is equal to that. Add. This is greater than or equal to that. Right. Add. And this is less than or equal to that. Right. Click OK, and I'm going to click on solve. And there you go. So these are the allocations. So like I said, because this gets the lowest return, we added minimum of 400,000. That's exactly what we did. And as you see, that's a constraint that is binding. This is also a binding constraint, as you notice. So the amount that we allocate to personal loans is exactly 60% of what we allocate to automobile loans, right? And this obviously has to be a binding constraint because it's an equal to constraint, right? So now let me go back to solver Let me click on solve again. This time I'm going to generate the sensitivity report because we need that. Sensitivity report for chapter. Oops. Okay, I guess there are too many. Okay. All right, so looking at the sensitivity report, let's answer the questions that have been asked, right? So first, how much should be allocated to each loan? We know that. What is the total rate of return that we are getting? So we are going to make $88,750, so which is about 8.875% rate is the total rate of return that we are getting based upon all the different things. So about 8.875%. Right? How did I get that? So you can take 88,750 and divide that by 1 million, which is the total amount of money that you're investing. So that'll give you 8.875%. All right. Now, if the interest rate on home loans increased to 9%, would the amount allocated change? So if interest rate on home loans increased to 9%, if you look at the allowable increase for home loans, so it's 0.07 and the allowable increase is 0.03. So you can increase up to 3.125% and it'll remain the same. So if you increase it by 2%, no, the allocation doesn't change. The allocation will remain the same because this increase is within the allowable increase of the objective coefficient for home loans. So home loans currently is at 7% and you can increase it up to 10.125% and still keep the same allocation, assuming that the other two don't change. So the allocation doesn't change, right? So that's the explanation. The explanation is the allowable increase, allowable decrease range, right? Okay, so that was that question. Now let's go to the second question here. Okay, suppose the total amount of new funds is available was increased by $10,000. What effect would that have on the total annual return? Explain, right? So total annual return. So if you look at the budget, so budget constraint is $1 million. That's what we have right now. So you're saying if we have $10,000 more, how much will that affect our overall return? You'll notice that the allowable increase is essentially infinity. How much ever you increase, the shadow price remains the same. So this is the shadow price. So for every dollar that you that the budget increases by, your overall return is going to increase by 10.125 cents. So it's for every dollar you invest, the return will be about 10.125 cents. So if that's about 10% return approximately. So if that's the case, if I invest $10,000, so it'll be 10,000 times this, which will be $10,125. So if I invest $10,000, I'm going to get back $10,125. That's how much our profit will increase, right? So again, how did I get that? 10,000 is how much I'm increasing, and the shadow price is 0.10125. So 10,000, 1, 2, 3, 4, 5. So that'll be $10,125, right? What effect with them, right? Assuming that the ASB has the original 1 million in new funds available and that the planning committee agrees to relax the requirement of at least 40% of the new funds by 1%, how much would the annual return change? How much would the annual percentage change? Okay, so you're saying the 40% constraint that we had here. So instead of 40%, if we went down to 39%, so $390,000, how would that change? Now this is a binding constraint, so very likely it is going to have an effect. So because it's a binding constraint, you will notice that we have home loans at a shadow price of negative 0.031. So which means that if you increase this restriction, saying that instead of a minimum of 40%, if you make it 41%, then your overall return will go down because you're putting more money into home loans, which has the least rate of return. But if you're able to reduce it, then you're going to make more money. So for every dollar that you increase home loans, allocate more to home loans, your overall return is going to go down by about 3.125 cents. So the question is, if they agree to relax it by 1%, so 1% is from $400,000 down to $390,000, which means that you decrease it by $10,000. If you decrease it by $10,000, because the allowable decrease is 40,000, which is essentially all of it. Essentially, allowable decrease is complete. So if you decrease it by 10,000, so it will be 10,000 times. So because you're decreasing, it will be minus 10,000 times. This number here, it should give you $312. So that's how much your profit will increase. Why is the profit going to go up? Because instead of allocating that money to home loans, you'll either allocate it to personal loans or automobile loans. And in either case, you're going to make more money. And the amount that you expect to make more is about $312,000. Now, how will the allocation change? For that, you have to resolve the problem to figure out exactly how the allocation is going to change. But we know that the expected increase in profit is $312.50. All right. Okay. And that's pretty much it. So that answers all the questions here. So how much would the annual percentage return change? Again, so 312,000, you divide that 312, you divide that by 1 million. So that's how much extra it's going to be. So 312 divided by 1. And this, I want to look at it as a percentage. Okay, 0.03%, right? So that's how much the profit will increase by, right? And that's it. That's the final solution. So, hang on. So for the first one, this one we said 10,000. How much is the annual increase? That will be 10,000 times that. So that'll be 1,000. I'm so sorry. $1,012. It's not $10,012. I'm so sorry. It's $1,012. And this was, how did we get 10? Instead of just saying negative 10,000, let me say 390 minus 4. Right? There you go. 39,000 and 40,000. $31.25. That's how much it's increased. Yeah, I forgot another zero here. I'm sorry. $312. I don't know why I keep making that mistake. Okay. So this was 10,000. So yeah, 10,000. And there you go. And these are the answers, right? Okay, I'll end this video here. And that's the idea. So when you have questions like this, you answer them as sensitivity analysis questions. Okay. All right. Take care.